Welcome back to the channel. Today we're working on part 2 of the Supercharged Dakota's short block machining and assembly. We've got everything set up and ready, so Tim can keep moving forward. The block's ready. It's already been bored and honed previously. We did touch up the hone again. We'll go over clearances later on that, and we've got everything set up for the next step.
Okay, we're ready to put the pistons on the connecting rods. We need to know which direction does what go. On the small block compressor, it's going to have exhaust valves at the ends of the heads and two together in the center, and your intakes are going to be in between them. So we've got exhaust intake, intake exhaust, exhaust intake, intake exhaust, like we wrote it down here. Now, if we're on the driver's side of the engine, would be cylinder 1, 3, 5, and 7. If we're on the passenger side, will be number 2, 4, 6, and 8. So we number everything like this, and since we're going to do the driver's side first, you can just flip your pistons over, number your cylinder on the front of the piston. On the connecting rods, if you notice, we've got a really wide chamfer on one side. On the other side, we have a narrower chamfer. This wide chamfer, the bearing is actually going to be just behind that. That side goes towards the crankshaft. And since the number 1 is the leading cylinder, that will be the front of the engine. So all of these will be oriented where the locks are to the right, big chamfer up and numbered. And then we put them together, we just number to number. We're good to go. Before you put any spiral locks in, always slide your pins through your rods and through your pistons, which we've already checked. Be sure everything fits. And then we go to the pistons and we'll put the rear spiral locks in first on all 4. And then for assembly oil, this is our preferred assembly lube. This stuff has what they call a high clean factor, where you can put it on something and come back weeks later and it doesn't run off, it just stays right there. So let's get started. We have a spiral lock already in the back. Pin's going to come through from the front, because that's how we're going to line our numbers up. So we're just going to get a little oil the back, oil the front, and then we'll oil the rod. A little bit on the pin, number to number, and that's how we'll do all of them. Okay, this is the spiral lock. This is what holds our piston pins in, and you can see this thing is twisted around several times. A lot of people will fight these getting them in. What you have to know, the hole that this is going to go into in that piston is smaller than this diameter. So you actually have to shrink it as you put it in. So all you got to do is get it in and hook under the piston in the lock ring groove, and then take the whole thing and just push it that way. And then you get it started. And just spiral it in. Just like that. Hold it. Then, be sure the piston pin moves back and forth just a little bit. Use about 10 thousandths. Be sure it's not in a bind. Everything floats easy. We're good. Okay, so we've got our crank torque down on the front and rear. We've got the number 1 piston rod assembly in. We haven't put the cap on, so I want to show you what we're talking about, the chamfer on that rod, how that actually sits. You'll see all that clearance that you have on that side, and you'll notice the bearing's real close to this edge of the rod. That's what you want to see. So when you put them together, look for that. If you have a rod backwards, you're going to have this over there or against the crank, and that will not work. Okay, we've got our rod torqued up. Now we're just going to roll this thing through. I'm going to see exactly where we're at TDC. Rocking back and forth. And it's going to settle in at about 3 thousandths. Now if you notice on this side, we have a dish in the piston. Normally you would check dead center of the piston. Obviously we can't do that here. And we can't really check the outside edge because of the piston rod is so much greater on the skirt side. And that's why we're checking on the edges like that.
Alright, we put one rod and one piston and chased all four corners of this block to get our numbers and get our clearance. This was 3,000 side of the hole, this was 3,000 side of the hole, fairly square. Now on this side, 5,000 side of the hole on one end, 3,000 in the hole on the other. So this end is not square. Also, this is why you do not roll lock your block. I didn't do this, I don't do this, but that's why, all wavy and pitted. So we're gonna fix that now when we deck it. Now, if you do this with a factory set of rods, the benefit of going aftermarket is the consistency, the rod length. The factory rods vary a little bit, and if you try to do this with factory rods, you're a little here, a little there, it's not going to be right.
Block indeed is crooked, so we're going to do a right at zero pass here, and it's going to cut heavier and heavier as it gets down there.
Alright, this is why you don't use a roll lock. You can see all the dips and waves in it. Now down here we were cutting heavier, all that's gone. But you can see even right here on the fire ring where the cutter is not touching yet. So do not use a roll lock on your block. Alright, we'll get the rest of this decked and squared away and we'll get back to you. Alright, we got the block decked, we got deburred, we've already gone through the final wash, we've installed the cam bearings, and we've already gone in and put the cam in and test fitted to make sure everything's happy. Now we're going to pass it off to Tim.
Okay, from here we're going to install we're going to walk you through the camshaft lube installation. There's a couple of things there that you don't get normally information wise, and we're going to try to cover that. We're going to move over to crankshaft installation, show you how to do that, set the thrust clearance, and then we're going to get into filing rings, getting them on the pistons and getting the pistons in the cylinders. So stand by and we'll walk you through it. We've actually run our camshaft through the wash, got everything clean. This is our camshaft lube that we use. We'll use it on the main bearings and rod bearings also. We have not had the first failure since we started using this, so we don't use anything else. Now, on the camshaft, we're going to lube the journals and the lobes, but what about the gear? If you've got a 200,000 mile engine and you've got an old intermediate shaft and a brand new camshaft, that's like taking an old ring and pinion, pulling the pinion, putting a new pinion on an old ring gear, or vice versa. These things need to wear in. So one, check your intermediate shaft. If it shows any visible signs of wear on the gear, just replace it. They do make an upgrade version of it. It's actually heavier duty if you run a high volume oil pump or anything like that. Other than that, what we're going to do, because we're going to lube this whole thing and try to get in the engine. So we're just going to slide the front journal in. That's backwards. But that allows us to get out here and start lubing the journals. And this gear, literally pack that thing with lube. You cannot have too much at this point. So we're going to do that. We'll get the whole thing lubed, and then we'll show you how to actually slide it in the block and not damage anything. Alright, so we've got everything very well coated with a good assembly grease, except this front journal is stuck in the block. So we're going to slide this guy out. We'll put a long 7/16 bolt in this thing, because you're going to have to thread it through 5 bearings, and try not to damage the bearings installing it. This gives us a handle out front. We're just going real gentle like, ease it through. It sounds rough when you do it, but when you're actually being very nice to it. All right, so now we've got last lobes in this journal. We're gonna get just a little bit of lube, coat the front journal, and just very gently, just like that. And that's it. All right, guys, we've got all our upper main bearings installed. These are a full groove bearing, which means the groove in the main cap's gonna, or the bearing in the main cap's gonna have a groove through it, just like the upper. The rear bearing on the Chrysler does not have an oil hole. So when you put your main bearings in the block, verify that not only do you have a hole for each to get oil through, but that they actually line up, because there are some engines like the FE Fords, they don't line up and you have to actually grind the block to clear it. So now we're going to set the crank in it. And again, watch the center main. That's all you got to watch. Set it straight down in it. And now we'll get the caps on, we'll oil all the bolts and get everything torqued, show you how to safety thrust. All right, guys, so we've got all the bolts lubed, everything installed, main caps tapped down. Our final torque's 85 pounds. We're gonna start at 40 just to get everything seated. Some people say torque from the middle out works for cylinder heads. Crankshaft doesn't really care. If you do middle out, you'll never be wrong. Okay, at this point we're gonna stop. The center cap on this engine carries a thrust bearing. It has a washer on either side that sets the end plate on the crankshaft. When this cap goes on, it could be to the front or to the back, 5/6 thousandths. It needs to be lined up square and on the back side, because all the pressure comes from either clutch or the torque converter. So now that we've got him pulled down, what we're gonna do, we're just gonna back this thing off to where that cap can shift. And then we're going to take a hammer. Believe it or not, it's the right way to go. We're going to tap the crank one time back. What that's going to do is use the crank itself. So if this cap is too far forward, it's going to shove that back to line up. And then we're going to go to the back and shove it forward. That's going to be the final position, and then we'll torque the cap. When we get everything final torque, we'll put a dial indicator on it, see what our end plate looks like, and it should be in spec. Double torque. All right, we're gonna go 40 to 60. And then final torque will be 85. I noticed we didn't try to rotate the crankshaft before we got them fully torqued. These bearings are press fit in this block the way they go together. Get everything torqued to final before you ever try to turn that shaft. Now we're going to get a dial indicator set up here. We'll measure the end plate and we'll be back in just a second. We've got our dial indicator installed. We're going to push the crank all the way back. Now bear in mind, we do have a little bit of lube on either side of these thrust bearings, so the actual running clearance will be a little bit looser than this, thousandths or so. And then we're going to push it forward. 5 1/2, 6.
Yep.
That's right on the money. That's as good as it gets. All right, so we're getting ready to file our rings, set the end gaps for the application. Now we open a ring box. It's been around for a minute, and it does not identify. There's rings here, and a bunch of rings over here. We don't know what ring goes where. What ring goes where. This will be the expander for your oil ring. That's the third ring down on the piston. These will be the little tiny rails going on either side of it. That's easy enough. But how about the top ring and second ring? If you notice, this one ring has a shiny spot in the middle, a little black on either side. This is a moly filling. That would be a top ring. Black would be a second ring. But if you do not have a moly top ring, it may look like this. So how do we know the difference between them? Notice this dot right here? If we look at the edge of this ring inside, it's a sharp edge. If you flip it over, there will be a bevel on the bottom. This ring is designed to load from the bottom coming down. This is an oil ring, second ring. As oil comes up behind it, that's what expands it. When we go to the top ring, whether it's smaller or not, you see the dot? The bevel is on the same side of the dot, always the top. This is a compression ring where compression comes down around the edge, inside, expands the ring around, and that's how you know your difference. So you gotta put the ring in the bore, just squeeze it together and turn it up fairly close to the top, because we're gonna push it down with the piston to square it up. Now, how far down do you wanna check it? If this engine was torqued with a torque plate or hung with a torque plate, it's going to be not round without the torque plate, and your ring gap will be off until you put the torque plate or the cylinder head on. That's the reason of honing with a torque plate. But that distortion will only go down about 2.5 inches in the bore. If we push below that, we've got an accurate measurement with or without. That's the best option. So we'll show you how we do that. We're going to take the piston in the bore and slide it down to about the tip of the skirt. This will put us just below the distorted area of the bore, and we can check the gap. We check it. When you go to pull it out, squeeze it together so it doesn't leave lines up the side of the cylinder or where the edges of the ring. Then we go to the ring grinder. If you don't have one of these, they're very expensive. If you want to buy one to do one engine, that's up to you. Other than that, have your machinist do it. If your machinist doesn't have it, one like this, you probably need a different machine shop. What makes this one work is that we have a stop here that we can rotate the ring based on the bore diameter, so that when we cut the one edge, we can put them together and we have a straight junction right there. That is important. We went ahead and got the ARP 4030 bore ring compressor. Notice it's not cut. This is only for a 4030 bore. This is our old adjustable. It'll go from 4-inch up to about 4080. You can tell by the way we've used it a lot, it actually works really, really good. But now check this out. So if we take the ARP and we roll it through, this thing's perfectly round. So you're compressing the rings all the way around evenly. When we go to the adjustable, by the time we get it set to where we have roughly the same clearance on the split, we can only turn it that far or that far because we have actually pulled it in on the sides. It still works good. ARP may be better. We're going to find out. So let's put the rings on. We've got our rings laid out. We have the oil ring expander, oil ring rails, second ring, top ring. Expander's pretty simple. Just expand it out. Keep the gap right here over the pin. Now when you put the rings on, it wants to jump over. That's always a problem. So what we do, we're going to hold, notice how I'm holding the piston. We're going to put thumb, finger, keep that together. We're going to take one oil ring rail at the top and we're going to come across that gap first. Now we've got that thing locked down where it can't move. We can roll it around. Then we're going to push the ring to us and we're going to hook this under to get the second ring, go around the gap first, and then just push the ring around the piston as you spiral it on. And that's it. It's that easy. Second ring, black face, dot up, bevel on the bottom. This will be a ring expander. First time you do this, it seems like you're being really mean to the rings. You're not. They're designed to do this. We're going to start him in the groove, and you're going to push the pliers pretty tight against the piston and just expand it out, slide it down, and it's on. Top ring, dot up, bevel up. No bevel on the bottom. Notice the face of the ring. That is a moly ring. Same thing. In the groove, hold it tight, expand it out. Rings are on. Rotate them through, be sure everything moves freely. All ring slides back and forth. Okay, so we've already cleaned the cylinder and installed the #1 piston so we could get our camshaft agreed. Now we're going to prep the rest of the cylinder so we can get the rest of the pistons installed. And what we're going to use is just a lint-free paper towel and automatic transmission fluid. See how dirty that comes out? And this block was washed, but there's always a little of that left behind. Still a little bit more. Now we're fairly clean. And then we're just gonna put a little transmission fluid in the cylinder. That's what we use for lube. We don't use motor oil. And that's how we prep the cylinder. Now we'll get the rest of them done and we'll get to the piston installation. We're gonna put the bearings in the rods. Just clean hand, run through, be sure there's no dust in there. Be sure there's nothing on the back of the bearing. Now if you had race bearings, you'll have a part number and it'll have a U or L for upper or lower, or it'll say upper and lower. If it does, the upper would go in the rod, the lower would go in the cap. These are plain bearings, we don't have to worry about that. Get the tang in first, slide it in. Cap, same thing, wipe it out. So the bearing's clean. Roll it in. All right, so we've got our Joe Gibbs assembly grease, light coat on all of our bearings. Now we're going to lube the rings. We've already got ATF in the cylinder. Our O-rings, we index the gaps over the skirts when we install them. Notice we have an eye here. This is for the intake valve relief. So we're going to spin the rings. And then we're going to put our second ring directly under the intake valve relief, and we're going to put the gap on our top ring 180 degrees out from there. Top ring gap over here, second ring gap over there. We're going to use our ARP ring compressor, and it is literally that easy, guys. Okay, we're going to put the #3 piston in. Rotate your crank to where the journal is all the way at the bottom of the stroke, and then we can get the whole piston in and not worry about the rod hitting the crankshaft. Big chamfer on the rod is going to go towards the crank. Valve reliefs are going to go towards the intake manifold. Be sure you got your ring compressor against the block, nice and square. Just like that. Now we can go in here. Hopefully. We can support the rod. Just like that. Okay, we're going to install the rod cap. Again, big chamfer towards the crank. And you'll notice the bearing tang here is at the top. Bearing tang on the rod should match. Get the bolt started, and then we're going to run them down by hand until they get a little snug. That's when you're right on the edge of that sleeve that has to go into the rod to align the cap. They say to tap these on, as long as you're careful. Just pull it up evenly. Snug it up pretty good. Remember, they torque 64 pounds, so you can snug it up like this. You'll be okay. Now, once you get to this point, you've added rings and you've added drag to the assembly. So if you're worried about the rod being tight on the crank, you can try to turn it, but you've got drag from the rings. But you can take the rod, if it'll slide back and forth on the crank like that, you know your bearing's not locked up, everything's oriented correctly. Now we'll get the rest of them in.
Alright, we're going to get all of our rods torqued, and we'll continue on with the next video. I got to order some more stuff and get it here. We'll get this short block fully assembled and go through everything with as much detail as we can. And then after that, we'll move on to cylinder heads. Thank you for watching.